All right, the mystery of Saturn's hexagon. That's our video today. You can see that hexagon up there in the polar vortex, North Pole, Saturn's North Pole. Saturn, we know Saturn, right? It's the second largest planet in our solar system, but it has the most famous rings, right? But the other planets, there's other planets with rings. Jupiter has rings, Uranus has rings, Neptune has rings, and there's even a dwarf planet way out there called Haumea. I'll write it down. Haumea even has rings. But Saturn's rings, let's use red over here. Saturn's rings can be seen from Earth, from a telescope. You can buy a telescope, get a good telescope. You can see Saturn, very blurry, but you can see its rings. You can't see Jupiter's and Neptune's rings, or definitely can't see Haumea's rings. So there's Haumea, dwarf planet way out there. It's about the size of Pluto. Let's get back to Saturn. Let's get back to that strange hexagon. And when we see hexagons, we kind of think that they're not natural. Like, we're not going to see hexagons in the natural world, but we do. We do see hexagons in the natural world, and we'll talk about that in this video. We'll talk about the honeycomb, because bees make hexagons for their honeycomb. But when our first thought is like, well, this must be man-made. This can't be real. But there is an explanation we'll talk about in the video. And by the way, all this is a hurricane. This is just a giant hurricane that you can fit 4 Earths in. You can fit 4 Earths in this little hurricane here. Well, we shouldn't say little. So we'll talk about that in the video. And if it's blue, as you can see here, this nice blue, that means it's the winter on Saturn. It's the winter season. And the winter season on Saturn lasts about 7 years. So imagine that winter lasted 7 years on Earth. We're saying 7 Earth years here. Imagine summer lasted 7 years. I'm sure a lot of students would love that. All right, so let's talk about the honeycomb. Let's talk about the hexagon, so maybe we can explain that hurricane in Saturn's North Pole. Maybe I'll change the color to green. So let me just say right here about the hexagon, the six-sided hexagon. So the hexagon is the strongest shape. There's more to this now. The strongest shape that, right over my name there, that uses, this is the key point here, it uses the least amount of energy. Now, of course, not by itself, but when you're using it to build something, right? So it's the strongest shape that uses the least amount of energy. And bees know this. It uses the least amount of energy. You can store, for bees, they know that you can store more honey. Store more honey at less cost. Because beeswax is expensive. Let's look at the honeycomb. So here's the 6-sided honeycomb. Change the color. Let's use red over here. So like I said, it's the strongest shape that uses the least amount of energy. And beeswax, the honeycomb is made of beeswax. Just made of beeswax. Just wax. Fix that little apostrophe there. What's happening? And beeswax is just honey and pollen mixed in with some enzymes. So if you think about the cost of beeswax, you need 8 ounces of honey to make that. So you better be cost efficient. You better be economical, and the bees know this. So basically the hexagon, again, write it over here again. Hexagon can store more honey than any other shape. While using less energy to make it. And also, we should write also, it is strong and stable. So if you think about if you're going to make anything to fill up space, you can use a square, you can use triangles. Now, triangles are strong. You don't want to use circles. Let's get a clean page here. All right, so if I made circles, excuse me, get the pen going. Stick with green. If I made circles, you can see as I'm making these circles, you're going to see gaps. So this is not efficient. You can hold stuff with circles, definitely, but you see the gaps? Put the gaps in red. There's gaps, not efficient. So you don't want to use circles. Now triangles are strong. They're very strong triangles. And you don't see any gaps, right? You can just keep creating these and you won't get gaps. Very strong, but as you can see, if you compare it to a hexagon, you can get more volume in a hexagon. I'll create a hexagon here and you can see. So triangles may be stronger than hexagons, but they're not going to have as much space as the hexagon. So if you see what I'm doing here, I just created triangles from the hexagon. So you can see the hexagon is not stronger than the triangle, but it is strong enough. The bees know it's strong enough and it can hold more honey. That's the key. And it costs less to make. It costs a lot more to make the triangles, as you can see from the picture. Just look at the picture. It costs much more to make triangles than a hexagon. So bees knew this. So let's get back to Saturn. So we have our pictures here. And I'll get my pen ready. Stick with red. So remember I said if you're seeing blue, right? Here you're seeing a different shade of blue. Then this is winter. And when it turns golden, well, that's summer. And remember, about 7-year periods we're talking about. 7-year periods. And this hurricane, remember we said this is a hurricane, and the diameter of the hurricane, end to end, could be anywhere between 15,000 miles or longer. 15,000 miles. Said we can fit 4 Earths in it. And each side is about 9,000 miles. So this is not some small thing. It's a 15,000 mile wide, and it even goes deep into the atmosphere of Saturn. So it goes down. If I make one here, let's make one 3D over here. It's going down into Saturn's surface about maybe 60 miles deep or longer. And we're getting more information on this. So this is a hurricane that is not just thin on the surface. It's going deep down into Saturn. And you think, well, it doesn't seem possible. It doesn't seem natural. But we did say that you can find honeycombs. Hexagons that are. You can find hexagons with bees. You can even find hexagons in our eyes, in the back of our eyes. Let me show you that. So here's the back of our eye, and there's the fovea. And it's a small area within the retina. And it's responsible for giving us that sharp vision in its cones. And the cones in the fovea are hexagonal. So there's another example where you can see them. All right, back to Saturn. And like we said, make sure my pen's ready. Let's use red. So the diameter we said was about 15,000, 16,000. Anyway, could be anywhere between maybe 16,000, right over here, 16,000 to 18,000 miles wide. All right, fitting 4 Earths. This is a storm. It is a hurricane. And there's other hurricanes surrounding it. There's other hurricanes surrounding it. Change the color for a minute. And like I also said, it's also deep. It goes deep inside of Saturn. And it could be 60 miles deep. 60 miles deep. And so what scientists think is happening here is that there's smaller storms pinching against it. Just try to make another hexagon over here. Make it 3D. So this is a jet stream is being pushed this way. The jet stream, you see this arrow. This jet stream is moving. It's moving as Saturn rotates. Now we have jet streams on Earth too. And the jet stream does move west to east on Earth based on Earth's rotation. Same thing is happening on Saturn. And so there are these small, I'll write it over here, there's these small storms. It's kind of pressing or pinching on the hexagon. And there's many of these small storms. They're all pinching and pressing against the hurricane, and there's not enough space. And so what's the best way to fill up that space? All these storms, not enough space. That's the way to think about it. All right, here. All these storms, let's change the color. All these storms and not enough space. So just like the bees, best way to compromise that is the best way to get the best economical space is by nature does it automatically. It's making a hexagon. That's the explanation now. Let me explain a jet stream for a minute. Maybe we can make you understand that a little better. So a jet stream, as you can see in this picture here, the Earth has 4 major jet streams. Here's one for the United States. So basically we have in our atmosphere, we have the troposphere. That's the atmosphere we live. And then above that is the stratosphere. That's where all the commercial jets are. When you're flying a plane, you go in the stratosphere. It's also where we have O3, which is our ozone, which protects us from ultraviolet rays. And between these two, between the troposphere and the stratosphere, is the jet stream. That's where the jet stream is. So warm air rises. We know that warm air will rise and it will meet this cold air. And what you have is the jet stream is fast moving winds or air currents way up in the atmosphere. And they do move, as you can see it here, they're moving west to east because of, guess what? Earth's rotation. And of course, it's moving in this kind of circular, or you can say a kind of a parabola over here, another parabola over there, in this cubic kind of equation. It's moving that way because it's bumping into mountains, right? The Earth has mountains. Saturn has no mountains. It has no land. So the vortex, the jet stream on Saturn, if we go back to that, doesn't have anything to interfere with it. We'll use green. We'll stick with green. There we go. So here it is. The vortex is moving. It's being pressed against. Remember, it's being pinched against smaller storms. And it moves the same direction as Saturn is spinning. Saturn spins east and west also, west to east also. And as Saturn turns, as it rotates, the jet stream on Saturn rotates also. And again, it's being pinched on by smaller storms. There's a lot of storms there. And to kind of make the space available, nature has created a hexagon. And of course, they're still studying this. So the best explanation as of why there's a hexagon there, it's not aliens. Let's use that color, by the way. There are many storms pinching, or pressing against the vortex, the hexagonal vortex, this. And so the easiest definition is there's many storms and not enough space. So nature takes over and creates a hexagon, which is the best available structure for space, just like the honeybees created their honeycombs to gain more volume of honey. And that vortex, by the way, we know that Saturn's 75% hydrogen, So the vortex will have hydrogen in it. They also think it has pneumonia, which is nitrogen and 3 hydrogen molecules of ammonia. All right, that is Saturn's hexagon.